live. Alrighty, folks. So we did this here. I'm calling this like the passenger section or the main body of the car. All right. Looks very beautiful. Note that I did change the appearance to be kind of a wood color. You can do whatever you want. I chose to make it wood color, but I mean, you can make it any color. All right, it's your car. We're going to make a new part. So if you need to make a new document, you can do that. But I am choosing to use one document called Automoblox Car. And I'm going to make each part a separate like tab, so to speak. So I'm going to click on this Insert New Tab, and I'm going to choose Create Part Studio. And this one I'm going to call the passenger plate or base. This is the colored plastic thing that's in the top of the wooden section we just made. It's got all the shapes, so it's going to fit right in there. And it's got like, mine has like a star, a triangle, a square, a circle. If you have the sports car, one of them, I believe it's the orange car, I think only has like 2. Is that true? Is that correct? I think we only have 2 people. Dude, if you're going to come in and get your stuff, then get your stuff. Like, I'm the middle class. So we're going to draw this, and I'm going to draw it on the top plate. Okay? You do you, but I'm going to draw on the top plate. The reason why is generally speaking, when I see the top, front, and right plane at the same time, I kind of want it to be in its natural position. And that is the natural position of that piece. So if I am now looking at this passenger base, the natural position, this is the top, right? And that's where I'm going to start drawing is that. So I'm going to actually make a sketch, not on the front plane, but I'm going to do it on the top plane. We're good? Yes, say yeah? Yeah. Okay. Then what I'm going to do is I am going to create just the overall outline shape. I'm going to start off with that. So I'm going to start with a rectangle, a center point rectangle. Okay. Clicking this drop down, center point rectangle. And I'm going to actually center it on the origin. Now, how wide is this thing? How long or tall or deep, whatever, is this thing? Well, you know, the thing is I already made these measurements because I already measured the width of this hole. Yes, yeah. So what you can do is you can just go back to the sketch that's called top hole, and you can go read those dimensions. Ah, yes. Width of 50, height of 40. So I'm going to use those same dimensions, width of 50 and length or height of 40. I'm going to use those same dimensions. So I'm going to go here now, width of 50 and a height of 40. So that should fit perfectly in that hole. Okay, I just use the same dimensions here. Similarly, I decided to set the radius for this curved thing, this fillet, to be 6. Okay, I set it to be 6. And so I am going to do the same here. I'm going to do a fillet, a sketch fillet, and I'm going to do these 4 corners to be the same radius of 6. So I have ensured it's the same exact dimension. So we good so far? Yes? Yay? And I'm going to extrude that.
Sorry about it.
I know that you do work.
No, I'm sorry.
You're not a dingleberry. I'm like so.
Did you see my slideshow I turned in for the AMI first one?
I think I did. I don't remember.
Well,
Did you have it turned in before class started? Or did you do it?
I like it. All right.
I will read your. I grade the ones I didn't grade today. I graded them all.
I mean, you can grade it, but just you should look at it.
All right. To get the depth, you're going to use this thing that sticks out. Okay. And you can use whatever hole you want. It doesn't matter. But you're going to get the height of this thing. Mine's kind of crooked. I don't know if you all have the same issue. Mine's like popped up and curved up. It's like too tight and it's kind of warped. So you might have to push it down some. Just be aware of that. Getting a height somewhere around 8 though. Okay. So I'm going to extrude this up 8. But you do you. So that's kind of my plate there. Questions? Okay. What I'm going to do now is I'm going to draw the 4 shapes. Most of you have 4 shapes. I believe it's the orange car. Only is 2. Is that correct? Okay. Mason, you're the orange car, right?
Yeah.
Who else have the orange car? Jay, you the orange car?
Yeah, man.
It's just the 2 people, right?
Oh, you guys have to.
So it will be a little bit easier for you, is what it is. But I would encourage you to pay attention because you really do want to pay attention to this. This is going to help you master constraints and tricks that you can use to draw shapes efficiently, even if they're quite complex or complicated. So you really need to pay attention to this. It's not about getting it done. It's about doing it correctly and efficiently. That's why I'm showing you how to do it. You should do it the way that I'm doing it. All right? Of the 4 shapes, square, triangle, circle, and star, which one's the easiest?
Square.
Okay, which one's the second easiest?
Circle.
Okay, which one's the third easiest?
Triangle.
Which one's the hardest?
Star.
Okay, so which one should we do first?
Square.
Okay, so we're going to do that. I would say that the circle is also pretty easy. You could do the circle first as well. But those definitely are the easiest of the 2, for sure. And then the triangle and the star is obviously the most difficult. So what I'm going to do is I'm going to do a sketch. I'm going to do a sketch on top of what I just did. Okay? I'm doing a sketch on top of what I just did. I could do it on the bottom as well. It doesn't actually matter, but I'm going to draw on the top. And I'm going to draw a square. So right here, I am not going to use center point rectangle. I'm going to just, actually I lied. I'm going to use a center point rectangle. I lied. Center point rectangle. Trust. You want to use a center point rectangle and just plop it there. Don't really worry about exactly where it is. Just put it in that corner, somewhere in that corner. Okay? Actually, I lied. Technically, that goes up here. There. Oh. There. My square goes up there. Okay. Now, the first thing I need to do is use a constraint. It's a square, right? Right?
Yeah.
So all the sides the same, right? Yeah. So right here, we have our constraints. Then there's a drop-down arrow right here that shows you a ton. Which one of these would help us make the side lengths all the same? Equal. Now here's the thing, right? You only need to do this one time. I'm going to click on equal. And all you got to do is just got to set this side equal to an adjacent side. Right? Yeah? Mm-hmm. Because properties of a rectangle, like opposite sides, are already said to be equal to each other. And they're already said to have right angles, the corners and everything. So, yeah. I only had to do an equal constraint one time. I just applied it to 2 equal or 2 adjacent sides. Are we good so far? Yes? Yeah? There you go. So now I'd have to dimension it. I'm going to give you a pro tip here. Don't dimension the hole. What could you dimension instead? The people, yes. You can dimension the people. So I'm going to go find the person, and I'm going to go measure the width of that square. And I'm getting almost 15. So I'm going to go with 15. So I have dimensioned the size of it. We're good? Yes? Yeah? Yeah? Mm-hmm. Now here's the thing with this. I've dimensioned its size. I have not dimensioned its location yet. I can still move this around. It can't change its size anymore. Okay, if I try, it doesn't, I just move it around. You can't change the size anymore. But we do need to figure out where it is. And so, unfortunately, you're going to do a little bit of ballparking because it's very difficult to get your calipers in there. I understand that. I'm sorry it is that way. It is what it is. So you're just going to like take your calipers and kind of just like hover them over and kind of eyeball it. I know it's not perfect, but there's no way to really get in there. Everything that you would be able to get in, there's going to be an angle, which means it's not going to be accurate anyway. So just ballpark it as best as you can. Remember, I'm only going the nearest millimeter anyway. So I found that it's about 2 millimeters from this top edge, which is the closest edge. So to dimension that, I click on the top edge, and then I click on the square, and then I click to place the dimension. And I'm saying it's about 2. About 2. We're good? Yes, yeah. The other one I'm going to ballpark as well. This one is a little bigger. Something like 5. Somewhere around 5. Okay. So I'm going to dimension that. That square should be completely black. We understand? Yes, yeah. Are we done? Maybe, possibly. I think the square is the starting point. I think it's the best one to start with. And you're going to see why in a moment, why I think this is better than the circle. Imagine trying to estimate how far the edges are to the circle. I mean, you could do it, right? But it's going to be more difficult. And then trying to actually physically dimension it, you're dimensioning to a curved surface. So like, where is it actually dimensioned to? It's not as clear cut. And so the thing is we can cheat. We can cheat because when we draw our circle, watch very carefully, okay? When I draw it, I can line the center of the circle up with the center of the rectangle. I'm going to show you how to do that. But I can line the two up. It's not doing a snap to constraint, but I can use a constraint to make them line up. Okay? And to do that, I want to go to my constraint drop-down list. Yes, yeah. And I'm going to choose horizontal. What am I choosing?
Horizontal.
Horizontal. And when you choose vertical or horizontal, what's up, man? Yeah, you're welcome. When I use the horizontal or vertical constraints, you basically either are selecting a line to make the line horizontal or vertical, or you're selecting 2 points and you're lining them up horizontally or vertically. So in this case, I want to line the center of the circle up with the center of the square. And so I have the horizontal constraint enabled. I click the center of the circle. I click the center of the square. It's lined up. And to prove this, if I click on the center of the circle, I can move it side to side, but I cannot move it up and down. Yes, we see that? Yeah. We're good so far? Yeah. Now, how big is the circle? I'm so glad you asked. You can measure with your calipers. Make sure you measure the circles correctly. Let me show you how not to do it. Do not do this. Why is this dumb? And it is dumb. Try it. I want you to try and measure the circle with your teeth like this. Try and do this. Why is this a dumb idea? The moment you try and do it, you'll realize it's not hard to figure out. You good, brother?
Alright.
Make it?
But yeah, I still 1.5 pounds, so I ate something.
How much do you want to do?
1.5,
I wouldn't eat too much.
128. Just like
No, you're under only a pound and a half. I wouldn't eat too much because then
I
you'll
know, I was
retain
gonna eat a
water.
Slim Jim. I was gonna eat one Slim Jim.
Yeah, just drink some water. Why is this a bad idea, guys?
It's hard to measure.
What's hard to measure?
The circle.
But like, be specific. You're not wrong, but like, be specific. What's wrong with this? This is not a good way to do this. Why? It's curved, and what problems that cause? It moves around, right? There's no good way to figure out whether you're measuring the maximal diameter or just like a part of the circle, right? But if we take our person and turn them like this, suddenly that problem goes away. We see this, yes? This is the winning strat. This is how you measure circles, if you can. Always measure it like this. We understand? Yes, say yeah? Because there's no way to mess this up now. All right? So measure your person. All right? Spoiler alert. It should be the same dimension as a square. Like, it should be. Okay? So, I'm going to dimension it to be 15 as well. Okay? Notice looks like a no smoking signal or symbol. That means diameter. All right? So it's telling us a diameter. You probably noticed, like on some sketches, there's the R for radius, right? There's the R for radius. This symbol means diameter. Now, we still have to place our circle. Stop. I want you to use some logic, though. How far do you think the circle is from the edge? Take a guess.
Same as a square.
That's not a bad guess, right? I mean, that might be wrong, but I'll tell you, it's probably pretty close. So when I measured or ballparked the distance that the square was, I got about 5 point something that was almost 5.5. So I rounded it to 5 because it was technically less than 5.5 rounded down. This thing is very similar, maybe a little more, a hair more. So I was going to go with the same 5. Now, if I tried to mention the distance from the circle, by clicking on the circle, to this here, it might work for you. It's fairly smart, and it does recognize what you're trying to do. So I'm going to show that again. I was able to do that. Did anybody not have the ability to make that measurement?
May I use yours?
Yes. Yep. So, everybody was able to do that? Yes, we're good? Okay. If, for whatever reason, you got to measure to a circle or some shape and you can't, right here is the point tool. You can literally just draw a point. And you can just place a point anywhere. So I can like place a point here and then make it horizontally constrained to line up with that, right? I could just do that. And then I could dimension to that point. You can do that if you ever are having issues. But yeah, 5. Easy. Problem solved. Okay. So we have the circle. Notice how we're using constraints and symmetry to save ourselves a lot of time. What shape should we do next? Triangle. I'm going to show you the quote-unquote proper way to do a triangle. I want to caution you, though, the center of the triangle does not line up with the center of that square. Do not make it line up. It doesn't. Okay? So, you could draw a triangle by using the line tool. And I think for a triangle, it's either or on which is faster, using the line tool or the polygon tool, because there's only 3 sides. But you already know how to do a rectangle, right? Unless you had to put it at an angle, you wouldn't use the polygon tool for that. If you had to put it at an angle, you could use the polygon tool. But typically, if you're using the polygon tool, it's for things that are like pentagons or larger, and you don't want to use the line tool for that. Way too much work. Right here is the polygon tool. We have an inscribed and a circumscribed. I'm going to draw them off to the side, okay, to show you the difference. I'm going to do the inscribed first. So the first click places the center of the shape. The second click gauges the size and orientation. And then, this is a little confusing, but after that click, you move your mouse in and out towards or away from the center, and that controls the number of sides. You can change that number later. So you can change that number by, just like the way you change a dimension, you click on the number and change it. You can change the number later, but how many sides does a triangle have? 3, which is the smallest you can have for a polygon. So that was the inscribed. Here's a circumscribed. What do you notice is the difference? What's the difference? Don't overthink this.
The circle is on the outside.
So an inscribed, and in geometry they use the same terminology in geometry class. An inscribed, the circle's inside. A circumscribed, the circle circumscribes, it's circumferencing it, okay? Honestly, it don't really matter which one you use for this one, but just go with your intuition. Which one do you think would be better? Left or right? I know what Jackson said. Okay, we got 2 votes here. Left or right, boys, what do you think?
Right.
Okay. I don't think either of those choices are like clearly, inherently superior. I am going to go with the left one because I don't need to use the circle, and I'm not going to use the circle. So I don't care about the circle, and because I don't care about the circle, I'm going to go with it inside so that the shape takes up less space. That's my reasoning. If I cared about the circle or had a reason to use the circle, like maybe I'm lining that shape up with another circle, I might care a little bit more. Okay? So I'm going to use this one. And I'm going to redraw it kind of closer. We'll zoom in a bit. I'm going to do the inscribed polygon. If you don't like the circle, okay, you could delete it. However, I want you to understand something. That the polygon tool helps you make a regular polygon. You guys know what that means when we say a regular polygon? What does it mean? What?
A closed shape with no curved lines. Contained shape.
It's more specific than that. The word regular has a very specific meaning. I can have a polygon, a triangle, it's not a regular polygon. I can have a quadrilateral, which strictly speaking only means 4 sides, right? So a quadrilateral, which is 4 sides, is not guaranteed to be a regular polygon. It's a polygon, but it's not guaranteed to be a regular polygon. I'll tell you that a square would be a regular polygon. What?
All sides are equal.
All sides are equal. That's what the polygon tool does. It already sets that up. So if you get rid of the circle, you're starting to take away some of the things that have forced them all to be the same. You understand? Yes or yeah? To prove that point, I'm going to click on this circle, and I'm going to delete it. And you'll notice now that it's no longer forced to be an equilateral triangle. So if you don't like the circle, you can just use the line tool, but then you're going to have to do equal constraints to make them all the same size, right? Which may or may not really actually be any better. But look at your plate and look how the triangle is oriented. One of the sides is vertical, correct? Yes, say yeah? Okay, so you're going to need to apply a vertical constraint. You're going to need to apply a vertical constraint. And in order to do that, you are going to go to the constraint tab and choose vertical. Now, don't click on the wrong side. Like this side's closest to being vertical, but if I click on that, look at the plate. Is that really the side that I want vertical? I really want the left side to be vertical, right? So if I click on that, it's going to be the opposite of what I want. I'm actually going to click on this one right here. And there we go. I clicked on this one. I'm not going to click on it again. I already constrained it. But trust, this one's constrained to be vertical. So I can still move my triangle around. I can still change the size, but I can't, like if I try to rotate it, it doesn't work. It just moves or changes the size. I can't rotate it anymore. Now, how big is this triangle? Okay, so when you get your calipers out, you are not going to measure a side length. I mean, you could try and do that, but I hope you can appreciate that trying to make this measurement is tricky. Do we see why this doesn't work out very well? Try and do it. Try and measure the length of a side. Like, it's not going to work out. What you can do, though, very easily, is measure the height. Yeah? I got the height? Yep. And I got 14 for my height. That was very easy. I feel very confident about that measurement. So I'm going to measure the height now. So I'm going to go to my dimension thing. I'm going to click on the point of the triangle. And then I'm going to click on the side that's opposite it. All right, 14. Strictly speaking, doesn't matter which point you use. But I'm going to use this point, so that's a perfectly horizontal dimension. I think it's just easier and crisper. At this point, that triangle is locked into its orientation and its size. The only thing now is, where does it go? Do not do this, just watch. If I were to line up the center of these, I want you to look at what I have, and I want you to look at your plate. Does that seem correct? I mean, it's not awful, but I feel like it's not correct. Okay? So I would not line up these two quote-unquote centers. Would not line those up at all. Okay? I would ballpark dimension it. How far are the points away? Okay? So for me, you know, it looks like it's probably a little bit less than the other number, but since I'm rounding to like a whole millimeter, it's probably going to be the same number. So I'm not going to use a constraint to line these up. I'm going to just dimension it. Because realistically, like I said, I am for the most part just going to the nearest whole number. And I don't know that it's actually closer to 4 than it is to 5. Just for the sake of being different, I'm going to put 4. But if you put the same number, that's fine. Don't use a constraint, though. If we ever wanted to go back and put more precise dimensions, those will clearly not be the same. You should be able to look at it and see that they don't line up. This point here really does not line up with this edge. I don't know if they're a full millimeter apart, but they definitely don't line up. And now, I just got to locate how far this bottom point is from the bottom edge. So I'm going to do that now. That's a very small number. It's probably 1 point something, but I'm going to just go with the nearest whole number, which is 2. Okay. If I was able to actually get in there, I might go with a decimal, because it's already kind of small. But I'm just going to go with 2. Any questions? Okay. I'm going to tell you right now, there is no way that we are going to finish the star. But I want to talk a little bit about it. I want you to use your big boy brains. Think about efficiency. What could I draw to help me draw a star exactly like that as quickly as possible? I'll give you a hint. You ain't going to start off by drawing a star.
Okay.
What? A pentagon. That, I think is what you meant to say. Pentagram. We're not like witches. We're not doing, well, I mean, maybe we are. I don't know. It is 2026. You can do whatever you want. But, what?
Lances.
Lances? We don't talk about that though. So, pentagon is a very smart choice. Because the pentagon not only has 5 sides, but it's already, if we use the polygon tool, they'll already be the same side length, right? That'll save us a ton of time. Now, I'm going to use your big brains here. What's another shape that I could draw that would help me do like the points? What?
Triangle.
Could do a triangle, but are those regular triangles? No. But they're all the same distance from the center of the shape, right?
Circle.
A circle would be a really baller idea, right? So if I draw a pentagon and a circle around the pentagon, right? Then I have shapes that can confine my points. And then all I gotta do is just draw a bunch of zigzag lines and apply equal constraints. And they'll already be shaped up correctly, right? We will start this and do it tomorrow. Okay? We'll start this and do this tomorrow. But you should have at least your 3 easier shapes already done.